Gold, one of humanity's oldest obsessions, is born not in vaults, but in fire and stone.
Each bar represents thousands of tons of earth, processed with extreme precision.
Modern gold begins with controlled destruction on an enormous industrial scale.
These vast scars in the landscape hide only trace amounts of precious metal. Often, less than a single gram of gold exists in each ton of rock.
Recovering it requires logistics, chemistry, and relentless mechanical power. To the untrained eye, gold ore looks ordinary, almost worthless. But hidden in SID is a metal that has shaped economies for millennia. This is the journey of gold, from buried rock to refined bullion. And it begins long before a single bar is ever poured. Gold processing starts at the mine, where geology dictates every engineering decision. Engineers analyze ore bodies measured not in kilograms, but in grams per ton. Gold rarely appears as nuggets, but as microscopic particles locked inside stone.
Drilling creates precise pathways for explosives placed meters below the surface.
Milliseconds of force fracture rock formed over billions of years.
Only selected ore is sent for processing. The rest becomes waste rock. Each truck carries hundreds of tons toward the processing plant.
Can I see your manifest? And what is in the back there?
Yes, it's all right here. Sealed industrial chemicals.
All right, looks good. Go ahead.
Different ore grades are blended to maintain stable processing conditions. The real transformation begins when rock meets machinery.
Dust control protects both workers and sensitive equipment.
Every stage is tracked in real time by automated control systems.
Consistency is critical when processing thousands of tons every day.
And pre-pruned asphalt. The first step is simple in concept, but brutal in execution.
Primary crushers reduce meter-sized rocks into fragments small enough for grinding. Steel meets stone with forces measured in hundreds of tons of pressure. Crushed ore moves continuously toward the heart of the processing plant.
Grinding mills pulverize ore into fine particles using rotation and impact.
Steel media collide relentlessly, breaking rock down into microscopic grains. Water transforms powdered rock into a liquid slurry ready for separation. Cyclones classify particles by size, maximizing grinding efficiency.
Oversized material is recycled until it meets exact size requirements.
Now chemistry takes over inside massive gold leaching tanks.
Cyanide solution dissolves gold into the liquid phase.
Gold forms a soluble chemical complex invisible to the naked eye.
Precise chemistry control is essential for maximum gold recovery.
Activated carbon acts like a sponge, absorbing dissolved gold.
Gold-loaded carbon is gradually separated from waste slurry.
Screens prevent valuable carbon from being lost with tailings. Each carbon granule carries microscopic layers of captured gold.
Heat and chemicals strip gold from the loaded carbon.
The concentrated solution moves toward final gold recovery. Electric current forces gold to plate onto steel cathodes. Slowly, dissolved gold returns to a solid state. What remains is impure but unmistakably valuable gold material. Moisture is removed before high-temperature smelting begins.
Temperatures rise beyond 1,000 degrees Celsius.
Flux binds impurities, allowing pure metal to separate. Unwanted materials rise to the surface and are carefully removed.
The first solid gold product is formed, known as doré.
Each doré bar contains gold mixed with silver and trace metals.
Every bar is weighed, recorded, and assigned a unique identity.
Security increases as raw material becomes concentrated value.
Doré bars are transported under strict security to refineries.
At the molecular scale, chemistry determines whether gold is recovered or lost.
The cyanide levels in leach tank 3 are fluctuating again.
Reroute the flow. Maintain the ORP below 400.
Once gold is removed, the remaining slurry becomes mine tailings.
Tailings storage is one of the most critical responsibilities in mining. Modern gold plants recycle most of their process water.
Residual cyanide is neutralized before water is released or reused.
Continuous monitoring protects surrounding ecosystems and communities.
Close the main valve, hurry! Turning it now.
Checklist is clear. Good job.
Gold processing demands discipline, precision, and constant respect for risk.
Artificial intelligence now fine-tunes gold recovery in real time.
Automation is reshaping mining operations from pit to plant. Sustainability is becoming a central goal in modern gold engineering.
Researchers are developing new methods to reduce reliance on cyanide.
Tomorrow's plants will be smarter, safer, and more efficient.
With careful planning, even mined landscapes can recover. The future of gold depends on responsibility beyond extraction.
After refining, gold reaches purity levels exceeding 99%. What began as dust becomes a global store of value. now. Its unmatched properties make gold essential to modern technology.
Few materials undergo such a dramatic transformation. Behind every ounce stands human expertise and precision.
Gold is not simply found, it is engineered. From rock to bullion, this is how gold is made.